Alright, Mr. Gatekeeper here. We got my my good buddy Mr. Lead Pipe Shorty. The Davemade 5-pill base. And there is quite a few Rainmaker repair and custom stickers on this thing. One, two, I think there's three, four, two on the back. So it appears that Mr. Rainmaker has worked on this box at least twice. Two, let's see, 1, 12, 11. And 11, 22, 17. Thought I'd go ahead and show that real quick. I just recently learned who Mr. Rainmaker was, man. And I had never heard of him before then. And he's done figured out a real neat way of, I don't know what you call it, transferring designs over to objects like copper boards and cases and stuff, and it's just absolutely astonishing. Just when I thought I'd seen it all, it blew my mind when I seen that. So major shout out to Mr. Rainmaker. It's really cool stuff, man. I'm gonna get him to do me a board or two on one of my candy builds, maybe a personal one for myself. A nice little cool design on some copper. But anyway, Mr. Lead Pipe Shorty sent me this, saying that he thought that there was some issues with one of the rectifiers, and yes, that's exactly one of the issues. There's at least one of these rectifiers that are blown. I'm saying one because I don't know if there's more than one, but there is one that is blown for sure. I just figured that out pretty quick. And we've got a couple other issues here too that I'm going to have to address. One issue which I don't know could possibly have something to do with the rectifier going bad. I don't know. I have no idea. But this bolt right here, let's see if I can't. See that bolt, man? That thing is oxidized. And this came to me just like this. Just like this. And it looks fairly burnt right here. I don't know if that was done heat shrinking these on or something. I don't know. I'm going to redo all the connectors on these wires. Well, I'm going to replace the wires. I'm not going to reuse these wires because these are 10 gauge. They may be 8 gauge, but I'm telling you, they're 10 gauge wires coming from the rectifiers over to the board. I'm just not real happy with the way that's done. I mean, you're possibly wanting to lean on 100, 80 amps possibly of current. 60 to 80 amps of current possibly flowing through this wire here in this pretty much 10 gauge wire over to the bus. So I'm definitely going to put some real thick 8 gauge wire on there probably, for sure, at bare minimum. I can tell this box has blown a couple of pills. You've got 3 different lot transistors in here. You can see we've got a 4D, a 4B, 9J, and 9J. And if you'll notice, the 2 on the left are dots, and the 2 on the right are non-dots. I'm not a big fan with mixing dots and non-dots myself, although, you can have either or matching each other, but the characteristics of the 2 transistors are different. That's why the dots are called A's and the non-dots are not. One's got beryllium oxide in it, the other doesn't, which does change the characteristics a bit. The non-dots are, let's put it this way, the non-dots have the possibility of being able to handle a little bit higher voltage without felling, and have the possibility of possible better heat transfer, a little bit, tad bit better than the dots, and have a possibility of handling more drive too. You hear how I say possibility, because there's some dots out there that have beat not. I've seen some dots have more gain than some non-dots. Toshiba never adapted a gain indicating system like Motorola did, so you can have transistors with a variety of different gains throughout the years. But anyway, next thing that I quickly notice, I'm sorry it's kind of dark in here because the box is kind of deep. Your input load, your input tuning capacitor has broke off, as you can see. That definitely is going to throw the input tune off dramatically. I don't really know, that might have been done through shipment, but here's one major issue that I'm going to have to address. Okay, I'm going to zoom in right here, and you can probably already see, and I've seen this in some of Dave's. This is an original Dave, by the way. Major shout outs to Mr. Sidewinder from the Gatekeeper. I have utmost high, deep respect for the original Dave. Without you, bud, I probably wouldn't be doing what I'm doing now. This whole world of CB, who know? I don't know where the world of CB would be without Dave. He definitely planted some seeds that are still sprouting. Let's just put it that way. But this has broke loose because, I mean, the only thing holding this phenolic board and this phenolic board together is a thin layer of solder, which originally is fine as long as the board is being held down with another means as well. But the problem with this is the only way this board is being held down is through the side here, through the, you know, the solder that's connecting both of the phenolics, and through the SO239s, and that's it. There's nothing else holding this board down, which I do not agree with. Somebody should have, you know, I'm not trying to be mean or nothing, I'm just, you know, telling you how I see it. Somebody should have at least drilled a bolt right here, somewhere, to compress this board down to the bottom of the box, which I am going to do. I have to do it. I can't let this go out here without me doing that. And preferably drill directly through the dang heatsink too, to give that thing a good firm hold to where you wouldn't even need this over here. But I'm going to fix this over here, and then I'm going to drill through there and do that as well. I can't let this go out the door without doing that, man. This thing needs to be, you know, very securely being held to this case, or something like that's going to happen. The next thing, the way Dave had these boxes designed is the whole back of the box ain't nothing but one big vent, which was, you know, the default way. You know, these boxes were used for a couple of different configurations. You know, I know on some of the configurations he'd have the it's like we got a little friend down there. Did you see that? A little spider. And I just got done cleaning the hell out of this box. I blew it. I sucked it, all the dirt out that I possibly could. There was a little bit of dirt in here and some stuff, some particles. I sucked it out. I vacuumed it out. I blew it out. I did it. Spent about 20-30 minutes cleaning just everything, you know, all the particulates around the box out. I don't know where that little guy came from. He must have been hidden somewhere pretty good. I just noticed the little tiny guy just walking on there minding his own business. I am out here in the garage, y'all. But back to what I was saying, this is about the most porous airflow that you can have. For one thing, I don't know about them fans that's on that top cover. I'm gonna have to check them out. I have a feeling them fans are not pushing a lot of air at all. They look like some Chinese knockoff LED fans, possibly. But I don't think this box was getting hardly any cooling at all through the heatsink. I mean, maybe virtually none through this heatsink with those fans. But as you can see, what I was trying to explain to you on the phone, Mr. Lead Pipe, as you see, this from here to here is about 40% of the box. Okay, you have a whole nother 60% of the box for the air to flow just out the back of the fins down here. Just blow up out the back of the box, just wasted air that could be forced through the heat sink out the back this direction. And so I mean, this heat sink's not getting a lot of air at all, if any, hardly at all. So I'm gonna have to wall this off down here. I'm gonna take my time and do it right, because I want to wall it off all the way to the bottom of this heat sink under here, so this air has nowhere else to go but under the heat sink out. And that's the next thing. I think Dave might have. Here's my hypothesis here. Here's what I'm thinking. At one point in time, Dave was using a heat sink that was a little bit taller, that covered the back of these fins. You see the back of the board right here? I've seen this in numerous Davemades, and I've also seen some Davemades where they were covered up mostly. But as you see with this, we've got a clear passage for air to flow throughout the back of the board. So by no means is this air, let me put it this way, by no means this is a forced air system for this air to be forced through the heat sink back out. So I've thought about with these days, how could I, make this airtight and make it look good? And I mean, because of the SO239s being in the way and the relay and everything, but the only thing I can think of is just silicone. Honestly, I don't care the way it looks. What I care about is this box running cool, this box running sufficient, and the air being forced through the fins out the back and nowhere else. Nowhere else. I'm removing these rectifiers and putting a high-end rectified module in here. I would say just take all this out, throw two 50 amp switchers in here, and this and that. But I mean, you got two good working transformers here, and I mean, there ain't no need to make more work, which is going to cost you more money, but in a sense it would save shipping costs back to you. But you get to buy two switchers, so why spend money when you ain't got to, But a lot of guys would probably do that. A lot of these units are being upgraded to switch mode supplies, but hey man, I'm still a fan of the linear supplies. I know that I just hate they weigh a lot and everything. I'm gonna check this cap just to make sure this cap is big enough. We need at least 50,000 microfarad at the bare minimum for a 5-pill supply. So anyway, that's just a few things that I've noticed. I see somebody bypassed the sideband in here and cut that out. I see there's a 5-watt resistor right here on the back, and I'm going to go ahead and guess that Rainmaker might have done. I don't know who done it. It could be anybody. Just because these stickers right here don't mean anything. I can't sit here and tell what Rainmaker did it or not. But whoever put this in here might have put that in there, because we've got 3 different lot Toshibas, and there could be some mismatch causing a little bit of heat right here. Sometimes people strengthen up on the resistor on the combiner just to soak up a little extra heat sometimes, I've noticed. This looks like a precision 100-watt resistor. I'm going to check it just to double check. So Sometimes it's hard to read them things, but I mean, we got, let's see, brown, black, black, black. See, that's a that's a four-digit resistor. Big boys race hour, that's 1, 0, 0. Then add no zeros. So that, okay, that's a 100 ohm resistor. That's a 100 ohm, 2% resistor. Or is that 1%? That's 1%. Okay. And then right here in parallel we have brown, black, black, silver. That appears to be 1, 0, 0. Then go back 2 more spaces. Those appear to be 1 ohm resistors. If I'm looking at it correctly, I think those are 1 ohm resistors, which is fine. So pretty much you got a half ohm from the one pill to there, which is perfectly fine. I think those are like some 3-watt metal film resistors. I definitely like using them in some of my blue boxes. So yeah. The only other thing I'm not sure about is this variable. I'm feeling a little spot in here I'm not too sure about. So we may be replacing that too. We'll see. So yeah, I'm gonna do those few things that I pointed out. We're gonna get this dang box airtight, shall I say, to where it's only being forced out the heat sink to the back. And we might be giving you some new fans too. If those fans are what I think they are, I can't let that fan. So you're a little different, Mr. Lead Pipe. You're one of my buddies. So I'm gonna go even further to the extent and make recommendations and tell you that thing is not coming back to your house unless that thing is doing this and doing that. Which I'm that way with anybody, but you know, I can do it a little bit more looser with somebody that I know without seeming like I'm forcing something on somebody. All right, let me get on out here, man. I'm ate up 17 goddamn minutes, man. I'm a freak. I should be called Motor Mouth. Motor Mouth Gatekeeper. Goddamn. All right, bro. This is what I mean by voltage fluctuating. As you can see, 17.8 volts right here. I'm gonna key up on it. Oh, see it'll bump back up to 18. It's just the voltage is just kind of bouncing all over the place. It was even at 16 a second ago, but that is an indication that a diode is bad. One diode is bad. Diodes can leak, believe it or not. They can do some weird things at times. So anyway, I got the amp fixed, so the amp is working. The variable is bad, by the way, so I'm going to have to replace that variable. Just to show you what I mean. Crank this variable all the way back. Ooh, no output at all. So you should still get some output from it. It's got a spot right there. Right there. Ooh. 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 I'm gonna turn it a little bit past halfway. That's when it messes up. Oh, you get no output. So the variable's bad. I'm going to have to replace that for you. And get in here and replace these 4 bridge rectifiers with this bad boy right here. So far, every amp that I have, or a power supply or base box I have done this for is still out there working strong today. And I started using these about 3-4 years ago. So, but anyway, when I get everything unhooked, I'm going to check the cap just to be sure. Just to make sure the cap's working good. There's a few tests I can do on that. I can't actually test the capacitance of it. But there's a few things I can test just to make sure the cap's in good working order. So we'll get all that done and get the venting fixed for you and get this fixed over here. I finally figured out what really caused this is the board shifted. See, originally it was pressed up against like this right here, but it shifted a little bit, and I don't want to try to shift the board back, so I want to let the board stay where it's at. And then I'm going to put a bolt through the board so it's not going to be moving during shipment. And I may have to run up and get me some silicone, some clear silicone. I'm going to make this thing airtight, man. We want to keep this thing as cool as possible. Alright, we'll be back. Well, we got two problems with these fans right here. For one thing, these things are not spinning fast at all. I've got the camera right up next to them. I don't even know if you can hear any wind airflow on the camera or not, but I mean, I barely can even feel anything coming off these fans, for one thing. The other thing is they're turned the wrong way. These basically are the type of fans you can buy off eBay for literally $1. When I first got into the hobby, I remember buying like 30 or 40 of these for $1 a piece, thinking I was getting something pretty cheap for $1, man. And I got them and hooked them up, and quickly noticed that these things are more for looks for on a computer than anything for a case fan. So I already talked to you on the phone. I just wanted to let you see this. So they're faced the wrong way, for one thing, so they're not blowing into the box, onto the components and out the back. And so I hadn't quite made up my mind what fans I'm gonna put on here. I might throw some 24 volters, or if I put some 12 volters, I am gonna have to regulate them some form of fashion. I don't want it to be too loud for you, since it's going to be sitting right next to you, but I want it to push enough air to keep them transistors cool. Plus, I've spent all the time making this box airtight, which you can't hardly see. I'm going to turn on some lights here in a minute. It's pretty early in the morning, sun ain't came up yet. But we'll be back. I'm going to put you some good fans on this thing, man. It's going to give you some airflow. Alright, brother, well, I just got the fan off, and kind of looks like a typical old school Dave box. It is dirty, caked up, and when I see something like this, it just eats at the inner core of my brain all the way to my pineal gland to go wash it. I could just throw some fans right on here, man, and you wouldn't even never see all this dirt, but I can't help myself. I'm gonna go clean the bottom of this. Plus, it's been eroded, as you can see right here where it was on top of the box. A lot of times you'll see that happen when something is needing ground and it's not getting enough ground, and you will actually see it to begin to erode like that. You see that? So I'm gonna clean. You can see right here, because it's relying on this case for a ground, which there ain't nothing wrong with that. There's nothing wrong with doing all that. Keeps things a little cleaner. We're only having one wire going back into the bottom. Plus, if you ever take the top off, the fans will quit. So you can put the top to the side if you're wanting to test something, so you don't have to unhook the fans. You know, there's a couple of benefits to that. But I'm also going to clean the top of this so that when I put this back on here, it's going to be making a good electrical connection. Now, I'm going to try not to clean it real good. If I hit this with a SOS, it's going to take this anodized color off the bottom, which, you know, ain't going to hurt nothing. But there again, I may just go ahead and do that to get it good and clean. Sometimes a rag and cleaner only do so much for some of these older boxes. Top looks fine, top of it. Alright, I'll be back. Alrighty. I say that is clean, clean, clean. Alright, let's get the fans put on there for you. Alright, man, all done. Got the fans on there for you. 2 brand new Evercools. And as you can see, the voltage is a little higher now, since we have less drop, going from 4 diodes to 1 bridge. And the voltage is stable, instead of going all over the place like it was doing. That's another thing, you do get less voltage drop using these bulletproof modules, because if you think about it with these, at one given time when you key, there's 1, 2, 3, 4, 5, 6, 7, 8 diodes total in circuit. Then the other 8 are blocking. And the more diodes you have, the more voltage drop you have. And then with these, you have 1 bridge. So you got a little less voltage drop. That's why you have a little bit higher voltage. Alright. One thing I do want to point out, these are 2 50 amp transformers, okay? They do, whoever built it, which, I mean, Dave, I'm sure Dave done this, or unless somebody rewired it. They are not hooked up on the high tap. They are hooked up on the medium tap. So you pretty much are looking at like 75, 80 amps probably. So they're probably running like 35 amps a piece or something. It's on the medium tap. So your voltage is going to drop pretty low, around 13.8 volts or so. And if you ask me, I mean, the box is going to run cooler that way. You still have no problem getting a kilowatt out of it. It's getting enough current. It's just the you know, you got 3 primary taps you can choose from, and they're just different voltages and different amperages. And you know, you change one, you change the other. But they got everything wired up at a bus right here, so you could wire it to the high tap if you wanted to. But the way I look at it is just you know, a little easier on it. So we got your bridge installed, got new cables put on here for you, got some real good thick new concepts 8 gauge. I swear their 8 gauge is thick as some 4 gauge I've seen out there. Some good wire, that's why I use them. The cap was okay, so we left the cap in there. Ain't no need changing anything that ain't broke. As you can see, we've got you bolted down here now, okay? And this thing is not moving at all. You can almost pick the case up now by the board. So that board is not going to be fluctuating anymore. I went ahead and fixed this down here, as you can see. Had to get some high heat to fix that for you. I had to put some braid right there in between the cracks to kind of fill it in. You can't tell by looking at it. A notification popped up and cut me off. But anyway, after I bolted it down for you with a lock washer and everything, I didn't even have to do that right there. I mean, it was going to be, it was held down just fine then. But I went ahead and done it anyway, so you wouldn't have to look down there and see the side crack there. And I'm going to be zooming in a little bit because this box is kind of deep in here, you know. I went ahead and replaced your 100 picofarad cap right there that was broke. Okay. Got your new variable on there. Okay. That's a new old stock Russian variable. Them things are tough, man. I have yet to have one come back broke or burnt yet. Not not saying it can't happen, but they're tough. They're good variables. And this is the first time I've ever done this before. As you can see, I had to go purchase this from Home Depot just for your box. This is the first time I've ever even used silicone before, period. But the way I looked at it, I wanted this to be airtight for you. I wanted the air to only flow through this heat sink out the back. So I've got all the holes that was on the back of the board, which was just going to allow a lot of that airflow just to flow right out the back without even going through your heat sink. That is now airtight. Okay. I cut a piece of thin copper, which came from this right here. I custom cut that so that it also, because basically I could put it here to here, but there was still a little spot, because you know this board right here overlaps the heat sink by about that much. So I custom cut it to where it goes down up under the board and sits on the heat sink. So this thing's airtight, man. There is no air at all coming out of this box, but through the heat sink, through the fins of the heat sink. That is the only way air can come out of this box now. So now if I'll need to do this to another Dave, I'll know exactly what I need to do. And like I said, that clear silicone, it might not be the best looking thing in the world, but we're dealing with an old school box here. We're wanting performance. You know what I'm saying? I probably could have done a little bit better of a job, but the way that was done, I would have spent a couple more hours to take this board out and try to do some sort of fabrication to do that. So that seemed like the best idea for me to do at the time. So let's see here. Sorry, I know I'm shaking the camera. I'm sitting over here moving around. So everything else with the box looks good. The input reflect looks good. And this heat sink that this bridge is on is a hefty heat sink, man. That thing does, the heat sink is so big that this 100 amp module is sitting on. This is a 100 amp, 800 volt module. I have been using these now for 4 years or so, and I have not had one fail. And the guy that introduced these to me 4 years ago, Mr. Real Deal, he said he has never had one fail on him either. These are very expensive parts, and they are used a lot in forklift machines and stuff like that needs real strong jolts of rectified DC power on demand. I cleaned the box out a good bit. It was a bit dirty down here. I vacuumed it out, cleaned it up a bit in a couple of spots. And there you go, man. So we got this thing up and running. Got your two new Evercool fans, which is regulated. Okay. So there you go, man. So we'll go ahead and demonstrate. For me to unhook everything. Here, we'll key it up first with the top off, so you can see what the volts drops to. Alrighty. Dude, there's flow through. We got a 10 watt slug, even though it's hidden right here, but it's a 10 watt slug. Oh, there's your flow through. All right. This is a 4 watt radio, 4 watts RMS. Okay. You don't see a whole lot of burr, because that's another thing. This thing does have some attenuation on it. It's got about 38 ohms of attenuation on the variable. Normally with my 1x4s, I'll usually put about 10 or 20 ohms. But this has some attenuation right here. This is a pad, and I just went ahead and left it on there. I mean, Better be safe than anything. So this is going to cut your drive down just a bit before it goes into the variable. This is normally the type of pad you put on the 2x4, but I just left it on there. You ain't gonna see as much bird with my bench radio because of that at first, but you will get the bird out of it once you drive it a little harder. All right. Oh yeah. Oh yeah. Oh yeah. Oh yeah. So that's about 240 bird. Oh yeah. See right there, about 900 watts. Just hitting it with the small 4-watt radio. Here's your input reflect. Oh yeah. Looks great. Oh yeah. That's about only 100 watts. The voltage is dropping to 13.9 volts. So you're already hitting 900 to about 1,000. Oh yes, that's 1,000 right there. See, the RMS is so low, for one thing, because that attenuation. Now take a look at the variable here. All right, we're going to cut the variable halfway back. We're still on peak. Oh yeah, right there about 800. We're going to turn it about a quarter. Oh yeah. Oh yeah. Oh yeah. About 400 watts. All the way back. Oh yeah. Oh yeah. Right there about 300, I think it is. Which I wouldn't run it all the way back like that. I'd try to keep her somewhere around this area right here if I was you. Oh yeah. All the way up. Oh yeah. She's smoking, man. Alright, I'm gonna hook up the hot radio now and drive a little bit more RMS drive into it and see what it does. I hadn't hooked my hot radio up to it yet, so I'm gonna press pause and hook my hot radio up, and we'll be right back. You're gonna laugh about this, man. You are gonna laugh about this. Yes, I figured out pretty quickly I would not drive any more than about a 4 to 5 bird watt radio on this if I was you personally. Just check this out. This is 8 watts RMS, okay? 8 watts RMS drive. Alright, 1,000 watt slug. Go. Look at that. Right there at almost 400 bird. That is almost a dual increase. So I told you, it's that attenuation. See, if you knock that attenuation down, it'd be doing already about 300 or so just on the 4-watt radio. But look at that. Almost 400 bird. Go 400 bird. 400 bird. Now take a look at the volt drop, dude. 12.3 volts. God almighty. Almost 400 bird on 12.3 volts. Goodness. So that goes to show you, this thing's got some gain, man. This amp's got some gain, brother. If that could be sitting at 15 volts, this thing would be doing over 600 bird. Easy. If it's already doing 400 at 12.something volts. So yes, if you ever decided to drive a bigger radio like I just did just then, that was an 8 watts RMS drive right there, okay? And it was doing about 35, 40 peak. If you ever going to drive a bigger radio like that, you would need to hook these transformers on the high tap. But if you want this thing to last for you, if you want it to last, I would just keep a small radio on it. I mean, you're getting good peak watts out of it. You're already getting 200 something bird out of it. And I mean, I'll just go ahead and tell you like it is. I'm not getting hardly no dead key on it right now, but with a 1 watt dead key, I'm getting no dead key. Okay? Let's see here. Let's see what my bench radio. My hot radio, I mean. See, that's about a 50 watt dead key. And my hot radio's dead key in about 1.5 watts. I've got that set to about 1.5 watts. So if you're not going to be running a real high dead key, and you do have soldering experience, you could take these two, this resistor right here, the solder to the brown wire. You could take this off and put you a 10 ohm or 22 ohm, and your bird would come up. Okay, your bird would come up. But she's working good, man. I'm glad to be able to get her fixed for you. I love getting these old school Daves up and running. Let's unhook this right here. Let me see. I'm gonna get the top put back on here. And I got the dang coax. That's one of the big things, repairs of the box was getting it airtight for you, man. So this air, there we go. Oh yeah. See, before, man, that air would have been coming out right here. 60% of your air would have been coming out right there before it even, without even going through your heat sink. Now it's forced to go only through your fins on your heat sink and out the back. And I put some fans on there that wouldn't be super loud, but would give this box enough cooling. And it is blowing pretty good. Pretty good. I know that ain't a big demonstration, but it's blowing well, man. It's going to keep it good and cool. So there you go, man. Little Davemade 1 driving 4 bass up and rocking and rolling. Back in operation. New variable, new knob too. It's a new knob for you I put on there. I had to, because that variable uses a different shaft. It's a different size shaft on that variable, so I had to use a new knob. I could put you 4 new screw bolts on here too for the fans. Made them the old ones are a little corroded, so those are stainless steel. That's all I use is stainless steel. So basically, we got rid of these. So I'm gonna show you this right here. This right here is what was powering your amp, was supplying the DC voltage to your amp. This is 10 gauge. It says 10 gauge on it. Right there, 10 gauge. I don't know if I can, there you see 10 gauge. And that was your ground. And although it did have some other grounds, it was going to the bolts, which ain't no need to do now since I got the board grounded to the case very well. Oh, I take that back. I think earlier in the video I said this may be 8 gauge, but looks like 10. But no, this was 10 gauge. So somebody did have 10 gauge, and this was feeding the hot bus. 10 gauge is just too small for a 5-pill or a 4-pill. You need at least 8 gauge minimum. I like to use 4 gauge sometimes if I can fit it in the box. So we'll get the screws on here, man, on the top. And get this thing weighed and give you a holler. You got something like this needs to be done, give me a shout, and I'll do my best to help you out. Old gatekeeper right here around the northeast end of Georgia, getting down and I'm gone. Bye-bye.